Alright, let's start off by asking what are atoms? Well, you know what? Let's go back a little bit. What are everything? You'll probably say that they're a saying, which is right, but the scientific form is matter. Matter makes up everything around us, or generally every physical object in our enormous universe. But have you ever asked this question before? What are matter made of? To find the answer to that, we'll have to talk small. This is what I mean by that. They're the particles which make up matter and can't be seen with the naked eye, and they're called molecules and atoms. Molecules makes up matter and atoms make up molecules. So this is our topic for today, atoms. Atoms are the smallest particle that makes up matter as they make up molecules. The word comes from Greek word atomos, which means things that can't be split, since it is impossible to split atoms. But can we go even smaller? Is atom a round ball of stuff, or are there more depths to it? Well, first, when people didn't know a lot about atoms, they thought it was just a round ball of stuff. But later, scientists like J.J. Thomas, or Joseph John Thomas, Emerest Rutherford, and James Chadwick discovered that smaller particles exist inside the atom. They discovered the protons, neutrons, and the electrons, which lead us to the first question. What are the different parts of an atom, and what does each part do? Alright, let's start off with protons. It has a mass of 1 AMU, which stands for atomic mass unit. They have this unit because the unit we use in our daily lives is too big to measure the mass of these teeny tiny particles. They have a positive charge of +1. It plays an important role as it determines the identity of the atom. The proton is located in the nucleus. The nucleus is the center of an atom which holds the protons and neutrons. And this leads us to our next particle, neutrons. Neutrons have a mass of 1 AMU, which is the same as protons. They have zero charge, so they're neutral, which is where they got their name. They're located in the nucleus just like the protons, and they help hold together the nucleus, including the protons. Next up, we have electrons, which is the last of the 3 particles in an atom. It has a mass of virtually 0, which means that it has a mass so small since we don't measure it with a unit. In fact, 2,000 electrons have a mass of only 1 AMU. It has a negative charge of -1. It is located in the electron cloud, which surrounds the nucleus. It is also a very important particle in an atom as it is responsive for our reactivity. The electron cloud is the area surrounding the nucleus which contains the electrons in an atom. The positions of the electrons can't be predicted, and the energy on each electron shells are different. The outer shell has the most energy. Alright, let's move on to our next question. How do we model atoms? Well, before we actually start modeling, first I want to explain the actual size of the atom compared to the nucleus. If my entire atom was the size of a football field, my nucleus will only be the size of a marble. And please note that the marble and the field in this demonstration is not to scale. When we are drawing or modeling an atom, we're not going to actually follow the rule of the ratio, so we don't have to draw teeny tiny models and try to draw protons and neutrons that are like a million times smaller. No, that doesn't work good because it doesn't do a good job of representing the atom, so we'll have just to break the scale and draw something that can be easily understood. Take a look at this model. It seems right, but to reality, it's absolutely incorrect. But why? Well, the reason is because this model shows all the electrons on one shell, which is not scientifically correct because each shell has its unique requirements, and we'll get to that in a minute. But first, I want to show you an animation of the correct way to model atoms. Alright, so when you watch that, did you notice any patterns? I could keep on adding electrons if I want, assuming the number of protons is the same as electrons. But if you compared this model to the one that was incorrect, what do you notice that was different? Well, if you haven't realized yet, it is the number of electrons on each shell that matters. And these are the requirements for each shell. The inner shell, or the first one, can hold a maximum of 2 electrons. The second one can hold a maximum of 8 electrons. The third one can hold a maximum of 18 electrons. The fourth can hold a maximum of 32 electrons, and so on. And that is how we model atoms. Alright, let's move on to our second topic, molecules and compounds. So we talked a little bit about molecules in the beginning, but let's go deeper. Molecules is a particle made of 2 or more atoms bonded together. For example, this water molecule is made of 2 hydrogen atoms and 1 oxygen atom bonded together. But what is compound? Because an English word that is a compound is a word that is created by putting 2 existing words together. In science, the definition is similar, but different. Compounds are molecules that contains at least 2 different elements. Sometimes it can be really hard to remember about which is which, and here is a fact that will help you to differentiate between molecules and compounds. All compounds are molecules, but not all molecules are compounds. For example, you can either call H2O or water a molecule or a compound because it is made of 2 or more atoms and element, so it fulfills the requirement of both molecules and compounds. On the other hand, H2, for example, would be only a molecule because it has 2 or more atoms but does not fulfill the requirement of a compound as it has only 1 element, which is hydrogen. Alright, now that we learned a lot more about molecules and compounds, I want to ask the question, how do atoms bond themselves to become molecules or compounds? And there's 2 types of bonding which I will show you and explain to you right now. The first type of chemical bonds are called ionic bonds, and they form when atoms either lose or gain one of its valence electrons to become ions. The ions will be positively charged or negatively charged, which pulls the atoms together to form the molecule. An ion is a particle where the number of protons and the number of electrons are different, making it either positive or negative. For example, the formation of table salt where Na and Cl is a good example of ionic bonding. Since chlorine is stronger than sodium as it has more electrons, it will take away an electron from the sodium to form a full valence shell, as that is what atoms want so they can be stable. So now chlorine is negatively charged and sodium is positively charged. They will attract to each other and form a molecule. The second type of chemical bond is called the covalent bond, and they form when 2 atoms with the same strength or that the atoms can overwhelm each other share their electrons, which attracts the atoms together to form this bond. A good example for covalent bonding would be H2O or water molecule. The 2 hydrogen atoms both share an electron with the oxygen atom to help make full valence electron shells, so the molecules can be more stable, which is what atoms try to do all the time. Thank you for watching this edition of Niu Productions. I'm your host, William Niu, and I'll see you in the next one.